Hi, everyone. Welcome back to the second part of the fifth lecture in this introduction to phonology. Um, so let's take us, having now discussed what the function of underlying forms is supposed to be in phonological analysis, and perhaps we could say even in linguistic analysis more generally, let's think back, let's consider what some of our objectives as phonologists are in a broader sense. If we're trying to describe the phonology of a language as a whole, one, one way of trying to go about discovering the phonological processes of a language is first to look for instances of allophony. So look for instances in which two sounds that might be the same underlying sound occur in different contexts. But we also probably need some other procedures in order to try to discover all of the active and productive phonological processes that exist in a language. And here there are two approaches that we can adopt, both of which can be useful, as we'll see. Probably using the so-called dynamic generalizations often turn out to be more useful and more reliable. Let's first talk, however, about the so-called static generalizations. And by static patterns in a language, we intend to simply try to observe how sounds are distributed in a language. And in part, phonemic analysis, which we have conducted in the first 2 weeks of this course, was essentially based on static generalizations. That is, does a sound only occur before high vowels? Does a sound only occur before non-sonorant consonants, for instance? So these so-called static generalizations are statements that we can make about phonology, things that we can simply say about the phonology of a language, based on the patterns that are permitted, the patterns that are allowed either inside a word or even across word boundaries. So we ask ourselves questions such as, where may a sound occur? Where is a sound allowed to occur? Where is a sound not allowed to occur? And are two sounds in complementary distribution with one another? Here we should recall that the condition of complementary distribution was a necessary part of establishing whether two sounds should be considered to belong to the same phoneme or different phonemes. Let's contrast this notion of static generalizations with dynamic patterns now. When we look at dynamic patterns, it sounds more exciting, more energetic. Here we are looking for alternations that occur in the form of morphemes in different contexts. So the analysis of the English plural morpheme, which I just summarized, again, would be an instance of looking at a dynamic generalization. How does the pronunciation of this suffix change based on the context in which that suffix occurs? So to give a precise definition here, we can say that a dynamic generalization is a statement about the phonology of a language which is based on the conditions under which different allomorphs, that is, the different pronunciation variants of morphemes, can occur. And last week, in last week's lecture, when we began conducting some analysis of phonologically driven alternations, that already was starting to look at dynamic generalizations. Now, and our question behind trying to discover phonological processes through dynamic generalizations is essentially, what phonological processes exist in a language that can cause a morpheme to have different allomorphs in different contexts? Now, to explicitly contrast how static and dynamic generalizations can be used in trying to discover the phonological processes of a language, let's first look at some data from obstruents in English. So here we have some essentially monomorphemic words of English, so words that essentially cannot be, for the most part, cannot be divided up into two or more morphological components. And we will look at here the obstruents, the non-sonorant consonants, keeping in mind this general principle that in our feature system, the feature minus sonorant, any sound which is minus sonorant, is an obstruent, and an obstruent corresponds to the group of sounds consisting of fricatives, affricates, and stops or plosives. Good. So looking at this data, we can find that organized in 9, I've gathered it as follows. So we've looked at instances in which the first member, sorted by first member, and then whether we have the first member is a stop or a fricative. So we have clusters in this data like psa, ka, and pta, and clusters like fta. So for instance, in after and lapse and crisp. There we all have instances of voiceless sounds going together. And if we look at this data, what we notice here is that we find sounds which are voiced occurring together, two voiced sounds together, like bda and vda and vba, and voiceless occurring together, like kta, but instances of clusters like say for instance, bsa or dk are completely absent from this data. So there are no words occurring in English like laps, svir, or Neptune. As you can tell, it's difficult to actually pronounce the words in that way because those would be contrary to the phonological rules of English. So our question when we just look at these monomorphemic words is, well, why do we not find any clusters of obstruents where the sounds have different values for voicing? If we use the same obstruent voicing rule that we used in our analysis of the plural morpheme, this rule will essentially ensure that any underlying sequences, if they were somehow created in English, and indeed the morphology, as we've seen, does create such sequences. Remember mit here, when the word mit, a kind of glove, when it has the suffix za added to it, it creates a sequence of a voiceless obstruent followed by a voiced obstruent. And that rule of obstruent devoicing will ensure that any of these sequences where there is a voiceless obstruent followed by a voiced obstruent will be transformed into sequences of two voiceless obstruents. So just to demonstrate this and make this explicit, let's take those sequences p, z, s, v, and p, d through this process of obstruent devoicing. These would be transformed into ps, sv, and pta. That's precisely what the rule in 10 predicts would happen. And one interesting fact to keep in mind, we may have occasion, or we may have the opportunity to talk about this later in the course. We could also explain this pattern through a constraint, where here we use an asterisk to indicate patterns that are not allowed in the language. So a pattern, a sequence of two sounds where we have one voiceless sound followed by a voiced obstruent is simply not allowed in English, and it somehow needs to be repaired. And as the morphology of the plural morpheme suggests, it's repaired by devoicing a sound. But this static generalization, the information that we can extract, the conclusions that we can draw just by looking at monomorphemic words, also point to this same rule. Now, if we consider those English noun plurals once again, the evidence from the English noun plurals allows us to discover this very same, this identical obstruent devoicing process. So in terms of talking about a relation between a rule that we can write in order to explain the fact that these sequences of sounds, z, sv, and pd, never occur on the surface in English words, and how we can explain the fact that a voiceless s occurs after voiceless obstruents in the plural morpheme, that can be explained through the same rule, this rule of obstruent devoicing. We both the static generalization that we can make that, so here we have static generalization, here we have a static generalization based on monomorphemic words, words without involving any other morphology, is that there are no voiceless plus voiced obstruent clusters in the English language. There's our static generalization. The corresponding dynamic generalization that we can discover through the plural morphology is that we can observe, oh, the underlying suffix z becomes devoiced to sa when preceded by a voiceless obstruent, a voiceless non-strident obstruent. So looking at what this shows us is that we can look for the same phenomenon in two different ways in a language. So essentially, sometimes the same phonological generalizations, the same phonological processes can be discovered either through static or dynamic patterns in the language. But in order to really make sure, when we look at things from the monomorphemic perspective, just using these words that consist of single morphemes, to make sure that that rule is correct, that the rule of obstruent devoicing is really needed to explain that data in English, we would have to make two further assumptions. And those two further assumptions are the following. First, that there are, in fact, really no instances of a voiceless obstruent followed by a voiced obstruent in English. So that would require systematically looking at the entire vocabulary, the entire lexicon of English, and ensuring that, yes, there really are no words that contain such clusters. And finally, one would also want to see that if, for instance, a loan word, a borrowed word into English from another language did contain such a cluster, we would want to see that the phonology of English would change that, that cluster of a voiceless obstruent followed by a voiced obstruent into a cluster with two voiceless obstruents. So although looking at this data, the data in 8 here, is consistent with writing this phonological rule. That phonological rule helps to explain the fact that the data doesn't contain any of these voiceless plus voiced obstruent clusters. In order to really be sure that this rule actually exists in English, one would need to gather some more data in order to be sure that you're right. And for this reason, conclusions based on dynamic generalizations instead are going to be more reliable. And there are two reasons, I think, for this fact. So one is that you don't need to have observed so much data in order to draw a secure conclusion. Indeed, this data based on English noun plurals is sufficient to tell us that a process like the obstruent devoicing rule needs to exist in English in order to explain why words like myths, slaps, and myths are pronounced with a voiceless consonant at the end of the word. And secondly, a static pattern that exists in a language could simply be encoded in the lexicon. So when I say here encoded in the lexicon, what I mean is that when we see a word like after or lapse, it may simply be the case that, well, after is pronounced as after with a cluster of two voiceless obstruents because that's what's present in the underlying representation. And the same applies to the word lapse, and so on. That has a sequence of two voiceless obstruents, s, because that's how the consonants are specified in the underlying representation of that word. And if we consider that those that information may simply be saved in the lexicon, may simply be part of the phonological information of that word, then it's not necessarily the case that that corresponds to a phonological process of the language. So just to try to clarify this point once more, obstruent devoicing here, if we try to say that there is such a rule in English based only on this group of words that we've seen here in 8, we only need to assume that that rule exists if we ask ourselves the question, oh, what would happen if English took in underlying sequences like p, z, s, v, and p, d? How would we want to make sure that those clusters don't exist and are not allowed to occur? So for making sure that obstruent devoicing genuinely is a productive process, an active process of the inventory of phonological rules of English, it's much more helpful to look at data from morphology. So these instances in which we look at alternations in the form of segments that we take to represent a single morpheme, something expressing the same meaning, provide much clearer and straightforward evidence for saying that we need a phonological rule like obstruent devoicing. Just to refer to one other example, so hopefully we had in the exercise session time to talk about some of the Russian data, and that Russian data at the end of the handout for week 4 can also be accounted for based on either static or dynamic generalizations. So recall in that data that we see in these Russian words given in the genitive singular and the nominative singular case forms, we find alternations sometimes between voiced obstruents, as in pruda, pond in the genitive versus prut, pond in the nominative, or chleba, bread in the genitive versus chleb in the nominative singular. If you look at all of the data in the nominative singular, if you look at the last segment of the word, you can make a static generalization that there are no voiced obstruents at the end of the word. So in Russian data, we have a static generalization. There are no voiced obstruents at the end of a word. And that fact, that observation about the nominative singular forms and the phonological content of those words, that could be explained through a rule of word final obstruent devoicing, which says that if there is a non-sonorant segment and it stands at the right edge of a word, it becomes devoiced. And that can also be expressed as a constraint, once again, just as I mentioned that we could express our observation about about allowable clusters of obstruents in English using a constraint. In Russian, the constraint would say that we cannot have any, oops, there's an error there. We should read plus voice here, not minus voice. Our constraint should try to correct that in the handout. Our constraint for Russian should be we cannot have a non-sonorant plus voice segment at the right edge of a word. Now, if we compare different forms of the same word, different inflectional forms in the nominative and the genitive with one another, we can use a dynamic generalization to see that if the form of the stem found in the genitive singular corresponds to the underlying representation of the stem, so for instance, saying that, for instance, in the word for time, row number 8, if we think that the stem has an underlying z, then the rule given here in, we should say in 16, could be used to derive the nominative singular. So the form ras in the nominative singular could be derived through word final obstruent devoicing. And as we hopefully talked about in the exercise session, in the Übung last week, a rule of intervocalic obstruent voicing would over-generate the facts in the genitive singular. So it would incorrectly predict the existence of forms like truba with a voiced ba in the genitive singular. Okay, so that using that logic of the pattern of alternations between the allomorphs of the stem. So here we have what we, in the Russian case, we have what we would call stem allomorphy, because let's say, for instance, the word for time has the allomorphs raz in the genitive, but ras in the nominative. The word for pond, as we mentioned, has the allomorph prud in the genitive, but prut in the nominative. There we're looking again at a pattern of alternation. We have morphemes that have different forms, and trying to explain that alternation, trying to say why the same morpheme has different, is pronounced in different ways, is spoken in different ways, can be attributed to phonological processes. Okay, let's take a break here, and then we'll see why sometimes we really need to operate with dynamic generalizations in order to make decisions in a phonological analysis.